Hey everyone. Today we're going to look at a new type of solving systems of equations, and this one is using combination and elimination. Kind of the same, you might hear that phrase for a couple different things. It kind of means the same thing. Combination, basically, we're going to combine two different equations and do that by adding kind of columns or adding down at columns. So basically, what's going to happen is we're going to look for similar coefficients, and that means the same number in front of x's or y's, and then they're actually going to cancel out if we added the two equations together. So our first example that we're going to look at, and we're going to do kind of three together, and then you'll have some time to practice some different ones. The first one is right here, example number 1. And in this example, you can kind of see here that when we're looking for similar coefficients, everything's kind of lined up nice and neat. The x's are on top of each other, the y's are, and then the number terms are all lined up together. So that's neat. That helps us. It won't always be like that, but this is a nice first example here. So we notice that we have x terms here, and we have the same number, but opposite signs, 2 and -2. If we add those together, they're going to cancel out completely. And that's what we want to happen when we're doing combination. So this one's kind of set up nice and neat for us. Again, they won't always be like that. Before we start solving this, I want to go back and review the other two types of systems that we've solved, or the other two ways we've solved systems. The first way was by graphing, and the second way was by substitution. And I just want to show you that this might take a little bit more time to do graphing or substitution for this question. I'm not going to finish it, but just to graph it, what you'd have to do is get both of these in slope-intercept form. So for the first one, and you don't have to write this down, just kind of watch and see if it makes sense here. To get it in y equals format, you'd subtract 2x, and then divide by 3, so it's going to be -2x plus 11, and then each of those over 3. So you'd have to graph that, and that's kind of a weird one to graph because 11 over 3 is 3 point something, not quite 4, and then it wouldn't work out exactly neat. And the other one, if you solve the other one for y, it wouldn't work out too neat, and we wouldn't get a nice integer solution. So graphing, it would work, but it would kind of take a little bit more time. The other one we did was substitution. And in substitution, we always looked for an x term or a y term that was by itself. And here is one of those cases where we don't actually see that happening. We don't see a single x or a single y in any of these parts right here. You could still do substitution though. So if you did this one, and again, you don't have to write this down, just kind of reviewing here. You'd either solve for x or solve for y. So if I wrote this first equation out here, we could maybe solve for x, just picking one. So we get rid of the 3y, and we would get 2x equals -3y plus 11. And then we divide by 2. And 11 over 2 is either 11 over 2 or 5.5. So we could take that and substitute it in for an x in the second equation, right there. And we'd be able to do it. It'd just be a little bit harder because we have some decimals, some weird fractions, and things like that. So it takes a little bit more time. Hopefully you'll see today that combination or elimination works pretty well when certain things happen. So the first thing that's kind of nice here is, I always want to make sure the x terms are lined up vertically, the y terms are lined up, and the number terms are lined up, and that equal sign's in the middle of them all. So that's the case here. What we can do is we can actually add these together. And we're going to add in columns. And this is where you want to start taking notes and writing down here. We're going to add in columns. So for these columns to add together here, -2x plus, or 2x plus -2x in this first column here. If we add those together, that's 0x. If we add together the next column, 3y plus 5y is positive 8y. This is kind of the first time we've really ever added in column format like this. The next one would be adding 11 and 13, and that's 24. So what you'll see that we got when we added these columns together, notice all the x's, y terms, and number terms are all lined up. We have 8y equals 24, and we've already got rid of our x by doing that. So when we solve this, 8 times y equals 24. we'll divide both sides by 8. And we'll end up getting y equals 3. And that's half of our solution to the system of equations. So we're almost there now. We just have to figure out what the x value is. And just like in substitution, we're going to take that y value, what we got for our answer for y, which is right here, and we can plug that in either here in the second equation or into the top equation. It doesn't matter. We should get the same answer both ways. Now I want to kind of show you why that works. So let's write out actually both equations here. I'll do it in black ink, I think. So we'll write out both equations to find x here. So we have 2x plus 3, and instead of y, we'll put our 3 in there. That's the first one. And then just the second one there, negative 2x plus 5 times that y equals 13. I'm going to put that y equals 3, our answer, in there, in for those y's. I'll give you a second to write those down there. I'm actually going to move this guy down a little bit. So we actually now have to solve for x here. So to do that, remember we have y, we just need to find x. We have 2x plus 9 equals 11. We subtract 9 from both sides. And if you want to not write as many steps in this, that's okay. If you can mentally go 11 minus 9 and get 2, that's fine too. And then here, 2 times 1 will be 2. So we know our x is going to be 1. Or if we had divided both sides by 2. So that way we got x equals 1 with the first equation. With the second equation, we should get the same answer. I just want to verify that we would get the same answer. So we have negative 2x plus 15 equals 13. And again, we're going to just kind of do a few steps here, subtracting 15 from both sides. We get negative 2x equals negative 2. And hopefully here you should see that when we divide by negative 2 on both sides, we do get x equals positive 1. So the final solution to this system of equations is that point x comma y. We found y first and then x, but x is going to go first, which was 1, and y was 3. And that's the solution to the system of equations. Now the work that we did on the right side here to find x, remember we did it twice. We plugged them in, the top equation and the bottom equation, just to show you that it actually does work in both. You don't have to do that. You can just pick one, whichever one seems easier for you, and plug it in. So that was the first equation there. To check that everything actually is correct, I could actually get rid of all this here. It's just a step that we kind of don't always do, but we really can do to make sure that all of our answers are right. So we know our answer is 1, 3. So we can put in, instead of the x's here, we can put in the 1's. So 2 times the 1 there for x. So for x there. And then for the y's, if I get rid of the y, we can put in what we got for y, which was 3. So 3 times 3 and 5 times 3. And when you do the math here, it should be pretty easy to see. In the top equation, 2 times 1 is 2. 2 plus 3 times 3, which is 9, does give us 11. So that's working. And here we get negative 2 plus 15, and that is equal to 13. So now we'll look at the second system of equations, and here we'll actually have to do a different type of thing. It says we might have to either subtract one equation, and you can do subtraction actually. Instead of adding in columns, you can actually subtract in columns. I think that gets a little more confusing. So what I like to do is get the signs to be opposites, so that you can add them together and they would cancel out. So get the signs to be opposites, then add the equations in column format. And then this it's actually kind of a made up word here. This isn't anything like mathematical, but you can actually negatize an equation. You can kind of force them all to be opposite signs, and that helps out here. So here if we look in this system of equations, all the columns are all lined up nice and neat. So that's not always going to happen, but it does here. When all those columns add together, it's kind of nice here, but if we tried to just add them right away, and you don't have to write this down, oops. If we tried to add these together right now, we would get 9x and 6y and 0. You might think that 0 is nice, which maybe it is, but we still have an x and a y. We haven't canceled one out, so that doesn't help. So what we're going to do actually is we could subtract these equations, but we're going to go ahead and negatize one of the equations. We're going to make one the opposite signs, and it doesn't actually matter which one. So maybe we'll just pick the bottom one here. We're going to multiply everything by, that's a times, multiply everything by -1. So these equations actually become -5x, -3y, and +2. So I multiplied every term, left side and right side of that bottom equation, by -1. And now I can actually add those equations together. So let's go ahead and do that. We have negative signs in the bottom now, or opposites I guess I should say. So 4x plus, and we're going to add now, plus -5x is -1x. So that was that first column that we just added together. We just added this guy and this guy. Now we'll add together these green guys, 3y plus -3y. And that's 0y. I'll write it there, but you don't always have to. And then 2, because I should switch colors here. 2 plus +2 this time now is 4. So that 0y is really gone now. It's just -1x equals 4. And there we solve this for x now, dividing by -1. We get x equals -4. And we got half of our solution. So now once we have x, we can take it into either equation at the top and plug in x is -4. So we'll go ahead and try to do that here. Alright. So let's just pick that top equation. And we'll say 4x plus 3y equals 2. And we're going to put in -4 for this x here. I'm going to keep everything else the same. So I just picked that top one kind of randomly. It doesn't actually matter which one you do. 4 times -4 here is -16. Plus 3y equals 2. And we're just going ahead and solving for y here. So we're going to add 16. And that gives us 3y equals 18. So remember, we're doing order of operations in reverse. Here we'll divide by 3 on both sides, and we'll get y equals 6. So our solution here is the point -4, 6, x then y. And that's our solution to the system. And let's go back up and check our work here to see if we got it right. We'll go ahead and plug it into both. So we'll go ahead and get rid of the x's here, I will at least. When I get rid of those x's, we're going to multiply them by -4, because that was our x value. And then we'll get rid of our y values, and those were 6, right? So we're just verifying that this actually works out. Instead of the y's, we multiply by 6. So we just want to see if this works here. If we look at that top equation, just on the top part there, we'll see that we get, right up here, this is -16 plus 18. -16 plus 18 is +2. And then here, -20 plus 18. -20 plus 18 is -2. So that actually does work out. And you'll see I'm just actually checking that in my head there. If you want to write out the steps, that's even better. But you don't have to. Alright, next one here. And this is the last one here. We're kind of getting more complex here. Now you'll notice, or at least hopefully start to notice here, that when we look at these terms in these equations, in the top one and the bottom one here, notice now that the x's and y's aren't on top of each other, and the equal signs aren't on top of each other. We can't do anything yet until we get them all lined up. So what we're going to have to do is rearrange our variables here. We have to kind of get them into lined up on top of each other. And we have to still use our algebra solving rules in that. So what I'd like to do is kind of keep one format. So I'm going to say 8x minus 4y equals -4. So I put the x, then the y, then a number. So I kept that first equation the same. And what I have to do is line up the terms in the right way. So I'm going to get the x and y's all on the left side of that second equation there. So I'm going to subtract 3x from both sides. So on the left side of this bottom equation, I actually have -3x plus 4y. Okay, so I just subtracted 3x and put it in the first spot there. And now you can notice here, hopefully, that if we move this right under here, stretch it out just a little bit. Now, hopefully, they're all in the right order. I'm actually going to rewrite that because that's kind of ugly. Sorry. And everything lined up nice and neat. So we have -3x underneath the x terms, positive 4y, and then 14. So now we'll look and see, hey, if we add these things together, is anything going to cancel out for us? And here you kind of notice that if we do add these equations together here, the y's are going to cancel out because we have -4y and positive 4y. So let's start to add in column format. 8x plus -3x is 5x. The y's cancel out, and we get 10. So here you'll see this is actually going to be pretty quick here. Divide by 5, we get x equals 2. And we're halfway there. We have our x value, we just got to figure out what our y is. So pick any equation. Any equation there, top or bottom equation. Let's pick the first one there. 8x minus 4y equals -4. And putting in 2 for x. So we get 2 there, keeping that equation the same. 8 times 2 minus 4y equals -4. So we're just verifying and solving this here for y. We plug 2 in. When we do that, we're going to get 16 minus 4y equals -4. And just keep in mind of watch out for negative signs and things like that here. We'll subtract 16 from both sides. Watch the negative signs here. -4y, bring down that negative, equals -20. And we'll divide both sides by -4. And that gives us y equals +5. So our solution to this system is the point 2, 5. Let's go back up here and verify that this actually is correct. I'm going to kind of get rid of all my work here so you can really focus on what we're looking at here. We'll leave our point ordered pair there. I'm going to get rid of my, oh, I should have kept the other equation. That's okay, we can plug it in here though. Let's get rid of my x's first. So x and x, we'll put in 2 for the x's. And then for y, and I know you can't really do this on your papers, but you can kind of rewrite the equations as well too. When you put in the y, which was 5, we'll get right there, and right there. So 5 for y. Let's see if these work out. In this top equation, we get 16 minus 20, and that actually is -4. And then on the second one, we get 20, and 6 plus 14 actually is 20. So this works out. So that's kind of combination. The first example, if we look back through, first example we had to, oh, everything's kind of gone now, but we had the terms lined up. We noticed that these would cancel out right away by adding them. In the second equation, if we added them together, they wouldn't cancel, so we had to negatize one of them. We had to make one the opposite sign so that they would cancel out when we added them together. And in the third equation, we actually had to group them and arrange them first on top of each other and then go through and solve it with systems. So you now have a few examples to work on here. There's actually 6 of them on your own. These are the 6 questions you're going to work on, and the answers are on your sheet. Some of these equations are already lined up in nice and neat format for us. Some of them are going to go ahead and cancel out when you add them together. And then maybe, some of them are going to actually have to be arranged. So when you look at one like number 20, you actually have to put the x's in the same format. Careful, you can't just take this x and move it over here. You have to actually subtract it to get it to the other side. So it's going to be a negative on the other side. So watch out for those little things, and good luck as you're working today.